back to this part right here. So I'm making another one of these that's going to essentially accept a carbide scraper blade. Whether you screw on a piece of carbide like I did or braze one on really doesn't matter. But what does matter is the shape and how it's designed. So this is what I've done. I have this end right here that's going to go towards the tool end, which is a copy of what's happening right there. And then I'm modifying the other end to accept the scraper blade. And so that's what's going to happen right there. So I have a piece of 4140 is what I'm using. This is just an offcut second piece in case I screw up the first one. And I've already done the turning on the lathe. That's boring, so I wasn't going to show you that. So essentially it's turned right there to the correct diameters. And it was also, I've noticed the original one was also bored. I think it's bored just to reduce the weight, so I did the same thing too. I bored it in almost all the way 80 millimeters deep, and that reduced the weight. So what I'm going to do now is I'm going to cut the features on this end right here, which is that. So essentially do a horseshoe shape cutout, and then turn it 90 degrees and bore a 1/4 inch hole for the pin. And then I'll flip it over and I'll work on the other end right there. And that other end is going to be a little more interesting. It's going to be machined down to half. I'm putting in a keyway feature so that it helps lock in the cutter bar. It doesn't have to be there, but it's just a nice feature to have. Kind of just slides in there. And then there's going to be a couple of screw holes to screw that guy down, so it should be quite rigid. Because one of the issues with these machines is that it's not a biax at all. A biax is a real properly designed machine for this purpose, and when you put a lot of pressure down on the tool, you know, these things are going to flex. There's going to be a lot of pressure. There's nothing really holding it like in the biax. It's essentially just some screws and you know, hopefully sound design. So anyway, let me set up the camera here and we'll get going. Okay, so I think I'm going to start with a 1/4 inch roughing end mill. Show you right there, if I can get this in camera view. There we go. So not sure how this is coming up, but that's the end mill and the end mill holder. Alright, so got a roughing end mill, 1/4 inch. I'm going to go in 16.5 millimeters in this way. I'm just going to take off the first part, see if this works. That looks really level. So I've locked down my vise, and I'm going to re-indicate off the edge, come in the right amount, and drill a hole straight down. There we go. Okay. Yep, pin fits in beautifully. Oh, what a nice fit. Crap. Shit. Very nice fit. Good fit. There you go. should be it. Okay, I'm just going to clean it up and measure and bring you back. Alright, first spotting operation. There we go. You guys ever watch John at, what's his channel? Double Boost, I think? He's just awesome. I just love the way he works. He works so fast. It's awesome. You can tell that he's been doing this forever. Okay, I'm going to back this up a bit so I'm not deforming some of the threads when there's too much junk in there. Gives you a cleaner thread. There we go. Oh God, I fucked up. Oh my God, how did that happen? No. Guys, you won't believe it. I don't know how this happened, but I'm scrapping the whole part. Something shifted, and I didn't notice, and I gotta redo the whole thing. Fuck me. Ugh. Look at that. It's not centered. It's off axis. Oh. Oh man, that was just done. What a disaster. Hey guys, so this is a major screw up. I'm really choked. So you've seen from the previous video, I just finished making this part, and this is the replacement. This would have been the shaft for the sawzall, where you stick the blade in. This is the replacement shaft for the scraper blade, and just as I finished it, just as I was tapping the last hole, I had realized that I forgot to oh, I got a cat that's calling me. Let me pause for a sec. I don't know if you heard that, but there's our hungry boy that was calling me. Had to take care of him. I'm thinking that I might just do something else to see if it'll work. What I think I'll do here is grab a pencil. Is I'm gonna cut right here with the bandsaw, roughly at this neck portion right here. Just lob this right off. And what I'll do then is I will clean up both faces, and I will drill, center drill, this piece and this piece to accept a pin. One just like this, right, a hardened pin. And I will make this a press fit, and I will also use a structural adhesive. Let's see if I can grab it. Yes, I can. So I think I'm pretty sure I found out about this product on Robin Renzetti's site. You know, he talks about all kinds of exotic products. This is Loctite. It's the same company that makes your blue and red Loctite material. This is Loctite AA326. It's a structural adhesive. This stuff is expensive, and you use it with a primer. This is a Loctite SF7649, and I've used this stuff before for some other projects where I needed to do a structural connection, and man, it is incredible. it is incredibly strong. So my thought is that I will press these two together and have a strong connection, because the forces aren't that massive on this thing. So I'm thinking I'll be able to get away with it. One trick though, or one issue that I'm going to have to deal with is that this part right now, it's 4140, but it's not heat treated. And I'd like to heat treat this part along with all the other ones. I'd like to preheat treat all this. So I'll do my machining, and then I'll heat treat them. Because if I heat treated it before I did the machine, if I heat treated it after I put the pin in and all that, the heat treat will actually destroy the connection, because you can't actually take this apart with heat. So that's what I'm going to do. That's my plan, is to heat treat this stuff first, and then come back and you know, pin everything together